In this video, we're going to talk about 8.1 Objective 1, where we define concepts related to sampling distributions and inferences about populations. First, let's distinguish between a distribution of sample means and a distribution of sample proportions. A distribution of sample means results when the means of all possible samples of a given size are found, and the distribution of sample proportions results when the corresponding proportions are found. Next, what is a sampling error and how does it differ from other sources of error? In general, how does the sampling error increase or decrease with larger sample sizes, and explain. Sampling error is the random error related to using a random sample to establish a population parameter. It is different from other sources of error because it is not related to a problem with the sampling procedure or the data collection method. It cannot be eliminated. When the sample size increases, the sampling error decreases because more data is collected about the population. So that's B. What is a sample mean? What is a sample proportion? And summarize the notation used for these statistics in the table given down here. So the sample mean is the mean of a particular sample drawn from a population. It sounds very circular, but we take the raw data, add it together, and divide by the total number of things in the data set. It's called an arithmetic mean. And x bar has a formula of the sum of the x's divided by n. The sample proportion, p hat, is going to be x over n, like so, where x is the number of successes and n is the total number of trials. So it is sample proportion is a fraction or percentage or proportion with which some variable occurs in a sample. So I like to say that it's a proportion, percentage, I'll think of another P word here probably in just a second, but there's any of those or probability. Because this is one of the ways that we can calculate probability. And you see the letter P starting these words here. So proportion, a percentage, or a probability that's represented as a fraction or a decimal or a percent, that is the number favorable over the number possible, basically. So notation for samples, we have the sample size is a lowercase n. The sample size for the population is a capital N. So this is samples and populations. The sample mean is going to be X bar. We're going to see a lot of Greek letters over here. Population mean, since the means is letter M, is the Greek letter mu. M-U. You see that it looks both like an M and a U. Let's see if I can draw that a little better, like so. And your textbook is going to make it look more like a U with a long tail on this side. And it kind of looks a little bit like an M, if you can see that. So it's mu. mu for mean. Sample standard deviation, we're going to use the letter S for that. S for standard deviation. And we're going to use the Greek letter S, which is sigma, for the population standard deviation. And then the sample proportion, we're going to use a P with a hat on top of it like that. That tells us that it's a point estimate. And the population proportion is just going to be a P like that. So first blank here was lowercase n. Blank 2 is uppercase n. Blank 3 is x bar. Blank 4 is mu, like that. Blank 5 is s. Blank 6 is sigma. Blank 7 is p hat. Blank 8 is just regular old p. All right. And that is it for this video. We will come back next time and talk about 8.1 Objective 2. See you for the next video.